All right, so it's a little past 9, so good morning, everybody. It looks like the majority of class is not here, but it is reflected in this topic. How many people have turned in their midterm? So your midterm should be done, right? It was due, well, at 9 o'clock. If you did not do your midterm, so I'm going to be closing that today. So if you did not do your midterm, then you're going to have to email me to be able to do that. So and again, if you guys ever right have issues doing something or don't have time doing something, what we need to do is always communicate with your teacher. So I just got a direct message about that. So again, if something came up, you just need to email me. And you should always email your teacher if you're not able, like if something comes up and you're not able to do something. And I did try to give you guys, I gave you guys 3.5 days to work on it. So if you didn't have enough time, you just need to email me and we can figure something out. Okay? So make sure you email me. All right, next, I will be grading midterms today and tomorrow. So grades for midterms should be up on Skyward. A couple of things I do want to point out. So the midterm is only worth 10% of your grade. And it's supposed to be, are you guys picking up things from class? Are you retaining information? Please know that the majority of your grade, 80% of your grade, is assignments. And I've been sending out emails through Google Classroom to you guys to remind you to get assignments done. We do have an issue in this class with people not turning in assignments. And grades are being really impacted by that. So remember, there is no penalty for late work for assignments. So you just need to do the assignments. If you have issues doing the assignments, then you need to communicate with me and email me. If you need help with the assignments, I have office hours. I'd love to help you to do those assignments. You just have to let me know. If you send me an email, I can do my best to help you through email as well. But what's most important is that you guys are doing the assignments and getting the points so that you guys can pass and move on to the next trimester and get that credit. And it's really important that that we do it because this is right. The grading system will never be like this ever again. You guys, right? When we go back to school next year, we will not have 80% as assignments and 10% as tests. It will be flipped. It will be like 10% assignments and 80% tests. So this is a golden opportunity, guys, to get your grades up. So make sure you guys take advantage of that. And if you guys have questions, let me know. All right, so today, as we can see, we're going to be doing special angle and line pairs. Okay, so let's dive right into that. Remember, if you guys have questions during class, that you can use chat and you can use your mic to turn that on as well. Okay, so let's go ahead and start taking some notes. And always, right, all these lessons are on YouTube, so you can always go back and watch anything on YouTube, right? That's there for you. It's like taking notes for you, but you should always still be taking notes. All right, so again, we're doing 3.1 today, and that's what your homework is going to be off. So we're going to talk about 3 different types of line pairs, and then we're going to talk about 3 different types of angle pairs. So 3 and 3. Okay. So the first one we're going to talk about is parallel lines. And you've probably heard about parallel lines, hopefully at some time in your life. We're just going to talk about what it means in geometry. So parallel lines. So instead of one definition, I'm kind of just going to make a list of properties of parallel lines, and then we're going to talk about how we identify parallel lines. So for parallel lines, we're really looking for 2 things. So it's 2, and then in parentheses, I'm going to say or more. And the reason why I put in parentheses or more is because in our class, we're really just going to be looking at pairs of lines. Okay, but it could be more. 2 or more lines that never meet in the same plane. And that last piece is really important, and you're going to see why in just a little bit. Okay, so 2 or more lines that never meet in the same plane. I'm always a little blurry. I'm always a little blurry in this corner, and I don't know what it is. I've tried cleaning the lens, but All right, so two or more lines that never meet in the same place. Another way of thinking of them that's really important is the distance. So the distance between the lines are always the same. I should say is. It's better grammar. All right, so the distance between the lines is always the same. There's no L there. Jeez. All right, always the same. Okay. So that's the two key parts here. Two or more lines that never meet in the same place and in the same plane, sorry, and the distance between the lines is always the same. Okay, so a classic example of this is railroad tracks. So railroad tracks, right, the distance between the two railroad tracks are always the same because the cart, right, that's going down the railroad is a fixed width. And so that stays the same width. Now, parallel lines is a lot to write out. So instead of writing parallel lines every time, there's a symbol for it. So parallel lines can be written as this. So this is the symbol. This means parallel lines. Okay. So that's what we're going to use for parallel lines. It's just like two lines going up and down. And I'll give you an example of that in just a second. Okay. And so to do this example, so there's two ways of identifying parallel lines. So if I do, so let's do an example of parallel lines. So I'm going to test you guys a couple times today and see. So in chat right now, I'm going to have two lines, N and P. So in chat, I want you guys to tell me, are N and P parallel? So it's just a yes or no. So in chat, you're just saying yes or no. Okay, so in chat, can you guys say yes or no? Whoa. Okay, so judging by the responses, I have a class full of superheroes, except for one. I have one non-superhero. Okay, because it seems like all but one of you have a super... I don't even have this. You guys have a superhero ability. You guys are going to get paid so much money. Construction companies are going to love you because you know what? You can just look at something and be like, you know what? Those are parallel, right? Oh my gosh, guys. Like, you guys have a bright future. Now, for everyone, for me and the one other student that said no, we don't have that superpower. And what I'm trying to get at, guys, is you can't just look at something and say, oh, they're parallel. Okay? Now, you might say, okay, they look parallel, right? But when you're building something as important as a home, you can't just go by, oh, it looks like that's 90 degrees, right? Or that looks like they're parallel. You want to actually measure it and ensure because you're talking about somewhere people are going to live. Okay? So there's two ways to do this. Okay, so way one is to add in an extra set of arrows pointing in the same direction. So like this means they are parallel. Okay, so that's way one of showing two lines are parallel. Okay, and if I didn't make it clear, right? Now are these two lines parallel? Yes, these two lines are now parallel because it says they're parallel. You cannot make assumptions. You cannot make assumptions. Okay? You cannot make assumptions. So these are parallel, and so this is one way we can do it. Now, the way that your book likes to do it, the book likes to do it, I know, of course, I did it with blue, but the book likes to do it with little red arrows. And let me show you what the book does, because that's what your homework is going to be out of. So right here, we can see we have two lines. We have line N and line M. And then they use those little red arrows to show that these two lines are parallel. Okay? So the extra little arrows means parallel. All right. I gotta zoom back out, don't I? Okay. Oop. All right, so that's way one. So way two of doing this is to say it in a mathematical statement. So the other way of saying this would be they just go n is parallel to p. Okay, so that's the second way of doing it. And what this reads in English is this reads line n is parallel to line P. Okay. So you can show it graphically by adding an extra set of arrows onto your picture, or you can go, the line name is parallel to the other line name. And we would read this as line N is parallel to line P. Okay. So there's, again, two ways of naming it. One uses the symbol, right? So the symbol right here looks like parallel. It's kind of like railroad tracks, right? Without the brace in the middle. And then we use an extra pair of arrows. Now, it doesn't matter which direction the arrows are pointing, and it doesn't matter how many arrows. So I could put like 3 arrows as long as I put 3 arrows down here, okay? So again, we're just using a system of the same amount of arrows to show that they're parallel, okay? So in your book, you might see double arrows on both. That means they're parallel because we're going to get more complex with more lines, okay? So that's parallel lines, and this is how we know they're parallel, and this is how we say they're parallel. Okay. How are we doing so far, guys? Am I going at an okay pace? Are you guys able to keep up? Thank you. I appreciate the people who give me feedback, because remember, this is about you guys, right? This isn't, we're not watching YouTube right now. We're in class. So this is about you guys. Make sure you guys are talking and sharing so I can adjust as necessary. Thank you, guys. All right. So this next part, so that's our first one, parallel lines. So this next part, we're going to take a look at skew lines. Now, skew is a funny word because it means different things in different contexts. So you might have heard skew when it comes to statistics. If a chart is skewed, that means it's shifted left or right. But that's not what we're talking about here. And actually, a really interesting story. Statistics, you know, in colleges is often a different department. It's not part of the math department. So skew is going to mean something a little bit different here. Okay, so skew is going to be 2 lines. And it could be more, again, but we're just going to focus on 2 for right now. 2 lines that never meet. Now, if I stopped there, we'd all be confused, right? Because 2 lines that never meet, well, that's how we started out parallel lines, right? Okay, 2 lines that never meet. Well, skew lines are 2 lines that never meet in different planes. Okay, and it's kind of funny here because the word that makes it different is the word different. Okay, so 2 lines that never meet in different planes. Okay, so 2 lines that never meet in different planes. Okay, now to do this, I'm going to have to show you an example. Now, usually when I'm in my room, I'm able to point out things in the room so you guys can see, but I'm going to have to draw a shape here, which is kind of cool because skew lines, since they're going to be on different planes, it has to be 3-dimensional or higher, okay? So it can't happen because 2-dimensional is all in one plane. So if we're going to have different planes, this has to be 3-dimensional or higher. So what I'm going to do is I'm going to give you guys a crash course. We usually do this later, but I'm going to give you guys a crash course on how to graph 3-dimensional shapes. So what I'm going to do is I'm going to make a 3-dimensional box. And to do this, I'm going to start with a 2-dimensional rectangle. Okay, and your rectangle doesn't have to look like mine, but just draw a rectangle to the best of your ability. Okay, now what we're going to do is we're going to use this line relationship here, parallel lines. What we're going to do is we're going to draw 4 parallel lines. Okay, so I'm going to start at the bottom right, and I'm just going to draw a segment back like this. Now, however long a segment that is, I'm going to draw that exact segment parallel to it above it. And then I'm going to draw that exact segment parallel over here. And then for the 4th one, I'm going to save that one for the end. So I'm going to save the 4th one to the end. Let's not do this one yet. So just do the 3. Then I'm going to connect these. So again, parallel with its other part. I don't know how I'm doing. So I get that. And then what I'm going to do for the bottom part is I'm going to do the exact same thing, but I'm going to make it look 3D by doing dashed lines. So I'm going to go dash, 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 dash. And then what we get is kind of a 3D effect. Now, you can tell that my shape isn't perfect, and I've been doing this for a long time. So I do by no means expect your shape to be perfect. It just gives us a quick general idea of a 3-dimensional box. Okay. So it's just one way of doing a box. I think it's the quick and easy way, and it uses parallel lines. It's very nice. Okay. So now what I'm going to do is I'm just going to label 2 segments on this box. So the bottom front, I'm going to call A, B. So down here, right, this is point A, this is point B. And then back here, I'm going to label this C, D. So that's this one and this one. So again, I'm not labeling everything, just those 4 points. Okay. So I'm going to highlight these points. Okay, so AB here is in red. And CD here is in blue. Now, taking a look at these, notice how this red one is going left to right, right? And this blue one is going up and down. So my question would be, first, are they in the same plane? So AB, can you see, is part of the front panel and the bottom panel, right? See how it connects the front and the bottom? Whereas CD connects the right panel and the back panel, okay? So they're not part of the same plane, right? So this AB is part of the front and the bottom, and CD is part of the right and the back. So they're in different planes, okay? So that's checked. And do they ever meet? No, this one's going to go up and down. It's not going to ever meet this one going left to right. So what we would say here is we would say segment CD and segment AB are skew. Okay, that is that they never meet and are in different planes. Okay, now to give you guys a different example, let's go back to that chain track example. So let's say AB is part of a train track. Okay, so can you imagine we have our train tracks going like this? And then CD is, I don't know, a sign. Okay, so I'm just making a sign. So you have this train track and then you have a train sign, right? So that's maybe can give you a more realistic, right? This sign is not interacting with the railway. Hopefully, right? We don't want our train running into a sign, right? So this sign is skewed to the railroad, as in they're in 2 different planes and they're not going to meet. And we hope they don't meet because that would be very bad. Okay. Okay, so that's what skew is. It's 2 lines that never meet in different planes. I hope you guys are doing okay. We're just doing definitions right now. We're going to practice these in just a little bit. Okay. All right. Let's take a look. So the next one is going to be perpendicular. Okay, and you guys have probably heard about perpendicular lines, right? So we're just going to go over these again. So what is a perpendicular line? A perpendicular line are two lines that intersect. Now, intersect is just a fancy word for meet at 90 degrees. Okay, so it's two lines that intersect at 90 degrees. So remember, intersect is a word that is also just a root word of intersection. So you can think of this as roads. So it's two roads that intersect at 90 degrees. So like you come up to a stop sign and it's a 90-degree turn to get onto the next road. Okay, so that would be one way of thinking it. Okay. So let's do a quick example of this, and then we're just going to practice doing those three angle relationships. So let's see if you guys have learned anything from our lesson today. So in chat, I want you to tell me yes or no, this is a right angle. Okay, so again, I'm getting a couple of answers. So again, is this a right angle? All right, so I'm getting a mix. I'm getting a mix of answers. Someone actually answered correctly, but they I don't know if they knew that they answered correctly. So I'm getting a mix of answers. So I don't know. Maybe we didn't make it clear the last time. So again, if you look at this and you can tell the angle, construction companies are going to love you because you have a superpower. You're able to look at something and just say, yeah, that's 90, right? Okay. But we can't make assumptions. So no, the answer here is no. This is not a right triangle. Now, does it look like a right triangle? Absolutely. Could it be a right triangle? Maybe. Okay. So if we want to make and show that it's a right triangle, we need to either show that it is 90 or we're going to learn about ways to prove that it's 90. So again, remember, if I draw this box, that means 90 degrees. Now this is 90 degrees. Am I saying triangle? Well, if I connected B and C, that would be a triangle, wouldn't it? Yeah, no. Obviously that I am wrong, and thank you for pointing that out. I meant to say right angle. Yeah, this is, I mean, it's not even a triangle, right? Yeah. Sorry, usually when I teach geometry, we only focus on triangles, but, and we will get to triangles in a little bit. But yeah, I mean, this would be a right triangle now if we connected them, but this is a right angle. Thank you for, I misspoke there. Okay, so now that we know it's a right angle, I can write ray AB, and then the symbol for perpendicular is an upside down capital T. So I would say oh my gosh, ray AB is perpendicular to ray AC. And again, this right here means perpendicular. Okay. So if we know that this is 90, then we can say ray AB is perpendicular to ray AC. Okay, and that is perpendicular. And for some of you, this is going to be new. For some of you, this is going to be review. But that's cool. It doesn't matter because we're all in it together. All right, so what we're going to do now is we have 3 different line rules. So what we're going to do is we're going to practice using these rules. Okay? So make sure you have that down. And then what I'm going to do, and you guys don't have to copy this picture down. We're just going to practice identifying these line rules. Okay, so I'm going to get this picture. I'm going to zoom in. Give me just a second, get it kind of flat here. Make it nice and big, and get out of my light. Okay, did I freeze it? Excellent, frozen. All right. So we're gonna do a little activity together. So I'm gonna say the question out loud, and then I'm also gonna type it into chat. So I want you guys to name two lines, or two. They're not really lines. How about two segments that are parallel to segment CD? So I also wrote it down in chat. I want you guys in chat to send me two segments that would be parallel. Now, remember how I said you can never assume? So in this, I just want to point out a couple of things because I did say you can never assume, so you're being correct. Whoop! Lots of... Here, just a second. I have to erase this from a previous class. Not cleaning up. Ooh, that's not what I want to do. All right, here we go. Let's get rid of that. We're going to be doing that in a little bit. Outside. Ooh. Okay, so a couple of things I just want to make sure you guys are aware of. Because this is 90, and we're going to talk about this, and because this is 90, then these are perpendicular. So for this problem, I'm going to say it's safe for you. If it looks parallel, it probably is parallel. Okay? So there you go. Because this is a square box. Sometimes often referred to as a cube. All right, so now I've given you permission to do that. I want you guys to name two segments that are parallel to CD. Yes. Ooh, we got to be careful on that one. So if we take a look, so I'm gonna try to talk about everyone's answers, but I need more people to answer here. So again, we're looking for segments that are parallel to CD. So remember, they have to be in the same plane, and they have to not meet. Okay. So I should be getting a lot more people responding here. This is not okay, guys. I have 33 students, so everyone is capable of typing in letters into chat. See, and that's okay to have questions, guys. I appreciate that, and we're going to talk about this. So a lot of people are getting 1, so I'm just going to go ahead and highlight this. So again, we're taking... Ooh, that's not what I wanted here. I did the wrong... Here we go. All right. So a lot of people... So here's... let's take a look at CD, because I'm getting a lot of answers. So CD is here in green. Okay. I can go a little bit thicker here. And then a lot of people for their answer... This is the most common answer I'm seeing. AB. So right there, are these two going to be parallel? Absolutely, right? And we'll talk more about this later. And I gave you permission to say if it looks parallel, it's parallel. Right here, because this is 90, because this is 90, and that's 90, these two would be parallel. Now I'm taking a look at some other ones. So CD and AB. EH would not be, so EH down here. So someone suggested EH. So the problem with EH, look how it's on that front panel. It's not on the same plane as CD. So EH would not work. What else do we got? EF. Yes, that one would also work. So if we take a look at EF, right? So EF would be on that left side as well. So AB and EF or FE would work. Oh my gosh, someone got the hard one. Someone got the hard one. So the hard one, the most difficult one here, and I don't expect everyone to get this. So if you didn't get this, this is okay. It turns out that a plane doesn't have to be a side. So if I go like this with CD, there is actually a plane that looks like this. So it turns out that CD here is also parallel to HG. Now that's not going to show up on a test, and it's not going to show up on your homework, but I thought it was interesting enough that I was going to show it to you. The big ones, the big takeaways, right, are AB and EF, right? Those are parallel to CD. But GH is also, and I think one person got that, so that's really cool. All right, I'm going to erase all of this. All right. Okay, so that was question number 1. And remember, guys, like go ahead and ask questions. Like, there's nothing. I'm not going to say anybody's name, especially if you do a direct message. We're going to be doing that. Okay. HA would not work. So if you took a look at HA, so again, they don't meet, but they're not in the same plane, right? So here, maybe what I should do is highlight the planes. So CD is part of the top plane, and CD is part of the left plane. So you can't be parallel with that, right? Now, there's also this diagonal plane, but I don't want to lose people, okay? CD is, yep, parallel to EF. All right, cool. So let's do the next question. So a lot of your answers were skew. So the next thing I want to say is name 2 segments that are skew to segment CD. Okay, so I want you guys to name 2 segments that are skew to segment CD. So we're naming 2 segments that are skew to CD. So remember, with skew, they don't intersect, but they're not on the same plane. Okay, so we actually just talked about GH. GH, it actually turns out, is parallel, right? So GH wouldn't be 1. So I think that is a good one. So a good one here would be EH. Right? So EH is not going to meet CD, and it's not on the same plane, right? Remember, we said CD is on the top plane and the left plane. So this one's on the front plane, so they're not the same thing. FG would be 1. Okay, so again, we're thinking skew here. So those would be skew to CD. What was the other one? EH and FG. Yep. There's some more. We got some more. Ooh, oh yeah, GB. That is 1. And we have one more. I love this last one because you can say it as HA and it's like you're laughing. So boom, like that. So those would all be segments that are skew to CD. Okay? So part of your homework and what might be on your final will be like, hey, which can you identify a skew segment or a skew line? Okay? How are you guys doing? Are you guys doing okay? All right. So the last one, and here I'm going to type it again. I'm going to type it into the thing. We're going to name 2 segments. Helps if I spell segments correctly. Segments. I put the G after the M. So the name 2 segments that are perpendicular to segment CD. So you're going to name 2 segments that are perpendicular to CD. And I just want to highlight, because I kind of drew over it, this is a 90-degree angle right there. All the angles are 90-degree angles. It's a cube, and I can just tell you all the angles are 90 degrees. So this one should be a little bit easier. Okay, so what do we got here? I got them coming in hot. So we got DA. Okay, right? That's going to be perpendicular. Now, we can't use EF. EF doesn't intersect, right? So parallel means that they intersect, so they touch. So whatever segment we have, they have to touch. It can't be AB. That's parallel. So EF and AB are parallel, right? Perpendicular means it touches. So if it touches, that means one of the letters you use has to be either C or D. So CB. Okay. Notice, right? It intersects at C, so it's going to be 90 degrees there. We got a couple more, guys. Oh, so, yep, no one has said it yet. What other sides intersect with C and D? Yeah, there we go. DE. Okay, so that's perpendicular, right? And then what's the other one? So we got CB and then also CF. Yep. So what do we got here? Here's a recap. We got CB, we got DA, we got DE, and CF. And if you switch the letters, it's not a big deal. It's the same segment. Okay. So a lot of people, I saw a lot of variations of different segments. So all of these would be perpendicular. So curious HD. So HD. So the problem. So HD. So there's a couple of problems with that. First of all, HD isn't drawn, so we're not going to use that. But if you went like this, right? See how it splits. So if this was 90 degrees and this was a cube, we're going to learn about this later. That would be 45. So HD wouldn't work, and it's not drawn, right? All these other ones, you see how they're already drawn. And then GC is the same thing. They're not actually drawn in there. And then because this is a cube, and again, we're going to learn about this later, it would be 45. But we're going to learn about that second trimester. Yeah, and thank you for asking questions, because now you know. All right, cool. So that's what your homework is going to be like. That's what, if this were to show up on the final, that would be like. You're just going to identify shapes like that. All right. So that was a little practice there. And as always, guys, if you're doing something and you need help, you can always ask. I would love to help. That's what I'm here for. All right. So what we're going to do now is we're going to move on. So for the second half of class, we're going to talk about those angle relationships. Okay. So let's talk about angle pairs now. Okay, in fact, I'm going to make this its own little header. Okay, so angle pairs. So before we do angle pairs, I have to teach you guys one new vocab word. The new vocab word is transversal. Okay, now the cool part about transversal, it actually has two root words that you guys probably already know. So the first root word is trans. Okay. Now, you might have heard the word trans used in lots of other words. For example, you might have a trans-America flight, or a trans-Atlantic flight, or a trans-Pacific flight, or you might make a trans-Washington trip in your car, or you might make a if you were mountaineering, you might transverse a glacier, okay? Or you might know as transgender, okay? Trans means to cross. Okay, in a loose sense, in like a very like, yeah, that makes sense. Okay, and then versal, you probably have seen the word versal before, probably with universe or universal, right? Like universal health mandates that we have right now with universal mask wearing. So universal, una means one, right? Versal means everything, loosely. Okay? So versal. So like a universe is one everything. Okay? Universal means one set of rules for everything. Universal. Right? So if you have a universal mandate, that means it is everywhere. Okay? So a transversal is something that crosses everything. Okay? Now, what does that mean for us? It's going to be something that crosses everything. So something that crosses everything. Okay. Now, for us, it's going to be crossing lines, because all we're going to have is lines and angles. So, but that's what a transversal is in like the literal sense. Okay. So what we're going to do is I'm going to give you a picture, and I'm going to teach you vocabulary words through pictures. So that way it's a little bit easier to go just look at a picture and be like, okay, what am I looking at? And it should be helpful for your homework, and it should be helpful for moving forward. So again, what I'm going to do is I'm going to start by drawing two lines. Okay, so let's see if you guys have learned anything. So, are these two lines parallel? So in chat, type yes or no. Are these two lines parallel? So I have 33 students. So I should have... So again, I'm still getting mixed responses. So again, we can't know something is parallel unless it says parallel. So since there aren't an extra set of arrows on this, these are not parallel. Okay. So then what I'm going to do is I'm going to add something to this now. What I'm going to add is this line. And this line is a transversal. Okay, notice how it crosses everything. I mean, yes, it doesn't cross itself, but it crosses everything else in the picture. So we call this a transversal line. Now, what's important about a transversal line is that when it crosses, notice what happens. We get two groups of angles. I like to think of these as cities, and you're going to see why in just a second. So I'm going to label these angles. So we get 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and I'm just making up these numberings, right? I didn't have to number it that way. They're just numbers, okay, so that we can talk about them. Now, I have here two lines crossed by a transversal, and what's important here is, notice how they're grouped, right? I have 4 angles up here, and I have 4 angles down here, and they're connected by a transversal. So I like to think of this as 2 cities connected by a highway. Okay, right? So like down here, we can think, here we have Mount Vernon, and then up here we have Bellingham, and this is I-5, right? Okay, and then maybe this is the Mount Baker Highway, right? And then this is oh my gosh, why can't I think of the highway that goes up to Baker Lake? Oh my god. I feel like I'm losing my mind. What's that highway? The highway that goes through Cedro. Why don't I know this? Anyways, now I just feel silly and I just I can't think. Is it 20? Anyways. Oh man, why am I blanking on this? And you guys aren't helping me out, so I feel like I'm just gonna move on. All right, so we have 2 cities, and they're connected. So what we have is we're gonna have, now think about this, we already have angle relationships for within the city. So for example, the angle relationship between 1 and 2, that's a linear pair. 1 and 4, that's a linear pair, right? 4 and 3 is a linear pair, 3 and 2 is a linear pair. Right, and we have angle 1 and 3, those are vertical angles. Angles 2 and 4, those are vertical angles. So already within our little cities, we have angle relationships. So what we're going to learn about today is angle relationships that connect cities. Okay, so we already have angles relationships that are within the cities. Now we're going to connect them. Oops, I have less time than I thought. So the first one we're going to learn about is corresponding angles. Okay, so corresponding angles. So these are angles in the same location. Okay, angles in the same location, different city. Now, obviously, the different city part is totally made up. That's not a mathematical definition. It's just me helping you understand what's going on. Okay, so let's do some examples of this. Okay. So let's take a look at our upper city up here. So in the upper left, I have angle 1. So angle 1, again, angle 1 is in the upper left. So what's the upper left in the city down below? You guys can use chat. So again, because I don't have people participating, I have angle 1 up here in the upper left. So what's in the upper left down here? Okay, and that is correct. It would be angle 5, right? So if this is the upper left, then this is the upper left here. So 1 and 5 would go together, right? And these are both in the upper left. Now, you're not going to have to write this down all the time. I'm just describing why these are corresponding angles. They're both in the upper left. Okay, so that is my example. Let's close this out. Can you guys in chat, can you guys type what are some other angles that would be corresponding angles then? There should be 3 more. So in chat, write, and separate them with a comma. So I got angle 2 and angle 6, right? So they're both in the upper right. What else do we got? So we got 2 and 6. What's another one? Okay, so I heard 3 and 7. That's really good. So angle 3 and angle 7. And then I already saw the other one. That's angle 4 and angle 8. Okay, so those are all corresponding angles. So you're going from to different cities, same location. So the upper right with the upper right, the lower right with the lower right, the lower left with the lower left, the upper left with the upper left. Okay, they're corresponding. So you might be like, hey, Kreft, I live in North Mount Vernon, and I could be like, whoa, I live in North Bellingham. So then there we go. We live in corresponding parts of our cities. Okay, so there's that. All right, I got a couple more, and I don't have a lot of time, so I'm going to use more pictures for these next ones. Our next one that we're going to look at, I got to get this picture in here, is alternate. Now, I always get students who say alternative. It's not alternative. It is just alternate. 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 Alternate interior angles. Okay? Now, let's break down what this means. So if you work on cars, older cars, they're going to have what's called an alternator. And I say that because cars that are that have batteries in them, are run by battery, don't have alternators anymore. Okay, so an alternator in a car, what it does is it switches. Okay, so when you see the word alternate, it means to switch. Alternate between even and odd. Alternate. Okay, so but for us, we want to know what it switches. It switches, you switch sides of the transversal. Okay, so it's going to switch sides of the transversal. And then what does interior mean? Interior means inside. Okay, so if I were to draw a picture of this, and I'm really sorry, guys, I just don't have a lot of time, so I'm going to just draw a little picture like this. So if we look up here, remember, we already have angle rules for in the city. So we're going to connect the cities. So, for example, 4 and 3 alternate, and they're, and I should write this, right? This is the inside. So think of a sandwich. This is the inside of a sandwich, right? So we're on the inside, which means this is the outside. Right? So the inside is in between lines A and B. So 4 and 3 already have a name, right? That's a linear pair. It can't be 4 and 5 because it doesn't alternate. So the only other option is 4 and 6. So I can put a little star like this and a little star like that. That would be an example of alternate interior angles. So I can just use symbols, right? The other one would be the other pair of alternate interior. So there's only 2 pair of alternate interior. If I were to look at this picture, examples of that would be angle 4 and angle 6 and angle 3 and angle 5. Sorry, I'm running out of time here. I got one more we need to talk about, so get that down. And this last one is alternate. Oh, I have two more. I'm just going to make them really quick, guys. Alternate exterior. I promise this will take less than 2 minutes. These classes are really short. Alternate exterior angles. So an example here would be like this. So it's going to be the exact same thing, but on the outside. So I'd have a star, and then a square and a square. Okay, so alternate exterior, just it's the same thing as alternate interior, but they're on the outside. And then the last one, and these last one, guys, I know we're rushing to get these down. They're not as important as the first one. So that's why we spent more time on the first one. Okay, consecutive means one right after another. Consecutive. So I'm just going to draw a picture for this. So, and then interior means inside. So that's going to be like this and like this. And then like this and like this. Okay. Guys, you do have a really short homework assignment tonight. It is just identifying line pairs. It's identifying angle pairs. That's all you're doing. You're just identifying them. Make sure you guys are doing your homework. If you need help, please email me. If you didn't do your midterm, you're going to have to email me. I want to help you guys. Remember that the midterm's only worth 10% of your grade and assignments are worth 80. So you must be doing your assignments. There is no penalty for late work. Make sure you guys are getting that done. So once you get this down in your notes, that concludes our lesson.